All right. Good evening, all. Hello, all of you. Yeah. All right. Let's look at what we had learned last week first. Yeah. Okay. This is what we learned last week, right? I don't want to talk about this one already. So this is what we learned last week. So what do we have is last week what we talked about, the name of the force, Newton's third law. So every action, so that is an action here. So this is the action. The action is called weight, right? Weight, we use the symbol of W, right? And then there will be a reaction. This one we can call it as reaction, or we can call it as normal, right? Because it is 90 degrees to the surface for the object that is placed on the top of the table, right? You put it onto the table, then you gotta have a weight, action, and reaction, right? And if this object is not moving, so we can say R is equal to W. R is equal to W. The reaction is equal to the weight, where I show you the video of how do we get it. All right, so this one we can call it as, this reaction we can call it as reading of the scale. All right, you can see, not call it, we can see it like a reading of the scale. At timbang, I showed you last week, reading of the scale. So if the weight is 5 Newton, all right, weight is equal to 5 Newton. The weight is equal to 5 Newton. Of course, all right, the reaction, all right, the reaction, if this object is not falling down, the reaction will be equals to 5 Newton also, right? So this is what we learned last week. If I increase the weight, right, this one become 10 Newton. So this one gonna be 10 Newton, right? If this object is not moving, all right? This is what we learned last week. And that is other kind of forces acting on the object. Different situation will give you different name, all right? This one we call it a tension of the rod. This one we are going to call it tension of the rod, right? Remember, in the exam they will ask you to draw the direction of the force, right? So it is always against weight and tension. It will be the same. Weight is equal to tension. All right, so if the object that is moving with constant velocity, all right, constant velocity, so up and down will be the same. So R is equal to W, or the forward thrust is equal to the frictional force, right? Forward thrust here is equal to the frictional force, all right? Frictional force. If the object is accelerating, mean forward. If you accelerate, this one accelerate, mean the tension minus the friction. So T minus mu is equal to your net force, your resultant force, which is called as MA, which is we also done it before, right? Mass times acceleration. M times A, right? Which is, this one is not equal to 0. When we got an acceleration, mean we got this thing is not equal to 0. So we got a net force, right? So this is not balanced force. Okay? All right. This one I told you we are going to learn it soon, not today. All right. Here, for the object, you see there is no thread, no tali here, and then that is a weight, right? Weight, and then this one, no nothing hang it, all right? No surface support it. So this one we are going to call it as lift, right? Whereas the aeroplane, which is moving at a constant height, aeroplane that is moving with constant height, we are going to call it as W is equals to the leaf. W is equals to leaf. If it move with constant velocity, mean forward and backward will be the same. The thrust is equals to the drag. The thrust is equals to the drag, which is constant velocity and constant height. But anyhow, if the aeroplane is moving upward, is right like this, it is accelerating upward. So what happened when the aeroplane is accelerating upward? Right, you can see accelerating upward mean the lift force, it is more than the W, so that it will go up. And the forward force, right, not constant velocity, acceleration, when it accelerate forward, mean the forward force is more than the frictional force, right? Normally this kind of question they will not ask you to calculate, but if they want to ask you how, show me the calculation, the resultant force will be equivalent to ma. The resultant force is T minus G. T minus G is equal to ma. Alright, then you proceed with the calculation. This is what we've done before last week. Okay, and this is some calculation. I guess I don't want to repeat it already. Right, now this week we are going to see something harder. All right, not all joined yet. All right, never mind, I take one example. All right, rough surface. All right, let's say rough surface here. All right, I take this example. Find the frictional force. All right, if the trolley is moving with the acceleration of 2, right, F is equal to ma. The resultant force, resultant force is 20 minus the friction. 20 minus the frictional force. I call it as F faster. Right, ma. M is 3, acceleration is 2. Make sure this is ms negative 2, not ms negative 1. Right, m 3, a 2. Alright, so what we have is, I want to bring this one negative F to here, it will become positive F. And then 20 minus 2 times 3, it is 6. So your frictional force is going to be 14 Newton. Alright, this is what we learned last week. Now you need to pay back. You need to pay attention, because later I got a quiz for you, and this part, it is very, very important. Right? If you see Form 5 student in the group, they all ask about this one. Right? What is this? How to do this? Right? How to do this kind of question? This kind of question. Right? Mostly they cannot do it. And then I got a very easy way for you. Right? And you just follow. Right? You see this kind, then you follow this type. You see that kind, then you follow the other type. Right? I will do both for you. Right? But some of them you need to read. They don't ask that way. You use the easier way. No use. Right? You still need to write the equation. Right? Never mind. You don't understand what I'm saying here. Never mind. So we are going to start with the example number 13. Example number 13. A boy with mass 50 kg. It is standing inside a leaf. Alright, stand inside the leaf. Label all the force acting on boy. Alright, first one. Right, this one is standing in the leaf. So that is a scale. Scale is reaction. Right, I told you just now, scale is reaction. So this is a leaf. So we are going to label all the forces in. So this one is called weight. Right, this one is called weight. Weight is going downward, and then this one is called reaction. So this thing, it is moving or not moving, I don't know. The question haven't tell me yet. So I label all thing in. Right, this one is called R. Right, reaction. And then this one is called weight. Right, they will ask you to calculate later. Right, A. Now we are going to B. We are going to do B. Find all the value of the reaction. Mean this reaction will change if the leaf, what? If the leaf not moving, then what happened? So if the leaf is not moving, right? I mean, it is not going up, not going down. Mean it is in equilibrium, right? When it is equilibrium, mean the W is equal to R is equal to W. R is equal to W. whereas R is equals to mg. Weight is equals to mg. We have learned it before. Mg. Whereas m is the boy, 50 kg. 50 kg. Right? G, the question not giving you G here. When it is not giving you the G, you can take it as 9.81. It is inside the formula list. Right? It is inside the formula list. This constant, gravity, it is given to you. Right? So we are going to calculate how much it is. Take out your calculator. Right? We are going to calculate 50 times 9.81. Sometimes it might give you 10. Gravity as 10. Alright? They will give you gravity as 10. If they give you 10, you just follow. 50 times 10, 500. Alright? So this one is 490.5 Newton. Not giving you, you have to use 9.81. Alright? This one okay? Should be no problem, right? Still okay? Alright, number C. Moving upward with the acceleration. Now, this one I need to explain a little bit before we continue. Right? Now, I want to ask you, right? This is the lift, and then this is called R. This is called weight. This is called R. This is called weight. And this thing said it is, see it is moving upward with the acceleration. Mean this thing, it is going upward with the acceleration. Now, why this leaf is going upward? Why the leaf is going upward? I will just say why it is going upward, because R is greater than W. That's why it's go up. I repeat one more time. Why this leaf it is moving upward? Because R is greater than W. Now, of course, your teacher, I don't get it. All right, I don't get it. Why? All right. Now, as I showed you before, this is a trolley. Right? This is trolley. Now, if here got one friction, right? Got one friction, 5 Newton, frictional force 5 Newton. If I move it with less than 5, will it go up? No, it will not go up. So if I move it with 5 Newton, then it will start to moving with constant velocity. Am I right? This is what we learned last week. If I move with this one, I am going to put it with more than 5. It is 6 Newton or 7 Newton or 8 Newton. So what happened? Then this thing, it is going to move to the right with the acceleration. Why it is moving to the right with the acceleration? Because the force applied is more than here. Now, we got two forces here. You see, why this thing it is going upward? Because R bigger, right? Right? Because R is bigger, right? You just change the direction, rotate 90 degrees, you will see it is the same thing. So I'll name this one as, oh, this one is R, right? This one is W. You see why it is moving R? It is moving upward. Follow this direction. Why it is moving this way? Because R bigger than W. If R smaller than W, it will go this side, right? Because this one is not. This one is friction. If this one, then it will go down. If this weight is more, then it will go down. All right. Now I hope you can get the concept first, right? If you can get the concept, right, then we are going to start to do, right? Now it is moving upward with the acceleration, right? When it moves up with the acceleration, I'll try to draw it for you. Draw it out, it is easier for you to understand. This is R. This is R. This is W. And then I normally will label this one as A. I'll label it as A, acceleration. Right? So I'll do it this way. You see? Now because of this thing, it is going upward. This thing it is going upward. I will just say R. Alright. F is equal to MA. Net force R. Resultant force is equal to MA. Resultant force is R minus W. Why? Because bigger minus smaller. Always bigger minus smaller. No smaller minus bigger. Don't use W minus R. Why you said, why teacher, why R minus W? Because it is going upward. So R minus W. So R minus W is equal to MA. Now I want to build the formula. You can see some of the reference book they are using this formula, and I don't want you to use it. Why? Because you use it means you just memorize. You don't understand how it is work. Right? W is equal to mg, right? R that minus W is equal to mg ma. And then you can see this one R is equal to mg, you move to the other side. Or you don't want, you leave it here. It is okay. I put it in M. M is 50, the boy. Time G, 9.81. Is equal to MA, M, 50. Acceleration they gave you in C, 2. Right? So you bring to the other side, become plus. Right? So this one we have calculated before, which is 490.5. 490.5, 50 times 2 is 100. So you get your R as plus 100 is 590.5 Newton. And you can press the calculator to get it. Right? So 50 times 2, of course you can press the calculator, 50.2 times 2, not 0.2. Right? Plus, this one negative, bring to the other side. 50 times 9.81. You get it as 590.5. Right? I guess that is not that hard for you. And I told you that is a formula that you can refer to your some of the reference book is R is equals to M G plus A. M 50, G 9.81, A acceleration 2. And then you time it in. Right? You time it. You are going to time it here. Where 50 times bracket 9.81 plus 2. 9.81 plus 2. Plus 2. Then what will you get? You get 590.5. 590.5. Right? 590.5. You get 590.5. Whereas it is the same thing. Right? Why it is the same thing? Right? You can see this one is mg. You bring this one to here. Right? It's ma plus mg. Ma plus mg. They just factorize it only. Right? If you want to build the formula, you can build it on your own. Whereas I don't want you to memorize the formula. Right? D. Moving downward with acceleration. Moving downward. Downward mean when it is moving downward mean downward is bigger. If not, how can it going down? Am I right? Moving downward mean downward is bigger. So I want to draw this. This is the leaf. I don't want to draw the boy already. Right? So this one it is weight. This one it is R. Right? Now this thing it is going downward with the acceleration. Going downward with the acceleration, meaning that if it is moving downward mean W is greater than R. So your resultant force gonna be your resultant force gonna be MA. What is the resultant force? W minus R is equal to MA. Are you okay with this? W minus R is equal to MA. Because I want to find the error. I want to find this error here. This error. I want to find this error. But I don't want negative. So I want to bring it to this side so that it become positive. The error will be into this side. This is W. W is equal to mg. I'm going to write down. This MA, I am going to bring it to this side. Become minus MA. That's why you see your formula error is equal to MOG minus A. Just now, if go up, or most of the students, I see some of the students, they don't understand. They just take it at this way. Go up, G plus A. Go down, G minus A. Alright, go down. They memorize. But in fact, you can make it even easier than what you have. Alright, don't go and memorize. It is come from here. So now what we do is we continue. Alright, no need to worry. W mg mg minus r is equals to ma. Rearrange them. Alright, r move to the other side, ma move to this side. Mg minus ma is my r. If you want to write it, r, we write it mg m 50 times 9.81 minus ma 50 times 3. Right here, find 3, 3 d. Question D, the acceleration is given as 3 downward. Right, so you press your calculator, then give me your answer. Press your calculator to give me your answer. I will explain to you again later how to do why it is so. Right, no worry. 50 times 9.81, 50 times 9.81 minus 50 times 3. You get 340.5. 340.5 Newton. That's all. Huh? Are you okay with this? I hope you're okay. Now, this question, I suppose no need to do one, right? Why? Because you see the word of constant velocity, right? But anyhow, I still do it. I want to show you, right? It is the same. If you do it, if you don't want to do it, it is okay, right? This is W. And E, the leaf, it is moving upward with constant velocity. Upward, constant velocity. When constant velocity, you no need to see how much is teacher constant velocity. What is the velocity? You don't need to worry. Constant velocity mean equilibrium, mean up and down, it is the same. So if I don't want to ask you, hey, I don't want to do it, R is equal to, if equilibrium, if not moving, R is equal to W. If constant velocity, R is equal to W. If you don't want to do it, right? So R will be equivalent to W. W is mg. mg. R is equal to 50 times 9.81. So R is equal to 490.5 Newton. In case you want to do it, I just show you. Alright. Because of R is equal to MA. Resultant force. Now tell me, this is going upward with constant velocity. Constant velocity. W bigger or R bigger? Answer me. W bigger or R is bigger in this case? W bigger or R is bigger in this case? Just two choices. just two choices. W bigger or R it is bigger. If it is moving upward with constant velocity. Moving upward with constant velocity. W bigger or R it is bigger. I'm waiting for you. Two watts. How about others? If this thing it is moving upward, four. Sugar. How about others? 4 watts. All watt same. 4 more watts. I need 4 more watts. Move your hand. Alright. Come on, fast. Which one it is more? Alright, I lazy to write for you. Right? So R, yes, you are correct. R is bigger. So why R bigger? Because it's going up. R minus W is equal to MA. R minus W is equal to M. M is 50. Constant x velocity. Acceleration is 0. So 50 times 0 is 0. So you can move it to here. R is equal to W. That's all. Right? That's why we got R is equal to W. Right? Next time you see constant velocity, you see constant velocity, you see not moving, it is all the same. Right? You don't need to worry. Okay. Now, undergo free falling. Alright, I will explain to you later. And now I want you to understand how this thing works. Alright. Wait, Still remember last week I showed you balance? Okay. I show you a balance, Alright. Now, later I don't want to use balance because the balance take a lot of space. Right? Now, never mind. I started with a balance. Alright. What is this? This is 25 degrees Celsius. Right? You can see it. 25 degrees Celsius. So I got something pressed on it, then it will give me the reading, right? If I press more, then it will give me more reading. I press more harder, then it will give me more reading. I press lesser, I press little, I press little, it will give me less reading, right? Meaning that if you compress more, then it will give me more reading. Now, you see, this book, I am going to press on it, right? 0.5 kg, 0.5 kg, right? It will show you 0.5 kg, 0.4, 0.5. Right? 0.4, 0.5, right? 0.4 lah, whatever lah, 0.4 kg. Now, you see, when I move upward, when I accelerate upward, this book, right? Accelerate more. It accelerate upward, first question, accelerate upward, then what gonna happen? This one is going to compress more because it is pressed. I don't want to take this one. I take it this way. Alright. This is my balance. This is my balance. You are standing on the scale. You are standing on the. This is a scale. Right? Timbang. You are standing on the scale. So if I move upward, mean it compress more or compress lesser. It compress more. Right? You compress more, right? Am I right? So you see this one, when it is moving upward, so the reading become more compressed more, because it is like that. You are standing on it, you move upward, X rate upward. So like suddenly X here, I don't stand on it, no reading. But if you move it upward, it give me more reading because you compress more. So 590. Originally is 490, but become 590 because you're accelerating upward. Now, how about if it is accelerating downward? Accelerating downward means you are standing on it. If it is not moving, it will give you the reading of 490, right? If you don't move. But now you see, now I accelerating downward, like compress lesser already. I move downward fast. So now this one is still follow, but it is like not compressed that much already. Oh, you see the reading will be getting lesser compared to if you are not moving. You are not moving, 490. You moving upward, compress more. The spring, not spring, the balance, it compress more, right? If you're moving downward, it compress less, right? If it is compressed lesser. Now, now, are you okay with this? Now, if moving with constant velocity mean upward or downward, I don't care. So it is still the same as this because it's moving with constant velocity. All right. Now, if you understand this, all right. If you understand this, now, F. What is F? F is called free falling. Free falling mean now you are on a helicopter. Now you want to jump free fall. Free fall mean you terjun, you jump down. You jump down from the aeroplane helicopter whatever. Okay. Right. You jump. You want to jump, all right? Now 1, 2, 3, jump. You are going to compress the scale. You want to compress the scale, but the scale is dropping down, free falling. You also free falling. You both together free falling. What is the reading? I'll repeat one more time. You want, now I stand on here. I compress. Got table to support. Then you can read the reading, right? Oh, 490 Newton. But now I am on the helicopter. I said 1, 2, 3, jump, and then once you jump, you press the scale under your leg there, and then you try to stand on it. You want to stand it, then you go down. You want to stand, then you go down. Then what will be the reading? Guess. What will be the reading? Guess what is the reading for logical thinking? What is the reading? What do you think? Now, what's the reading? Hello? Don't know. Don't know. Anyone help me? Anyone help me? What is the reading? What is the reading? Come on. You are going to jump from the aeroplane or jump from the helicopter, and then you are going to move like that. You want to step on it, but tidak boleh. It is going down. You want to step, but it going down. You want to step, then but it going down. You keep on both going down together, like that. Can you compress the spring? Can you compress the scale? Can you compress the scale? You cannot, right? You cannot compress the scale. The reading will be 0. Right? The reading will be 0. But never mind. I am going to show you how to calculate it. Not enough space. I use too much space. Right? I do it here, okay? F, I do it here. All right, this is my leaf. This is the weight, this is the error. All right, I'm going to label every time when I do it. I am going to label it. It is easier for you to do and easier for you to understand. This is error, this is W, right? And then this thing, it is going downward with the acceleration. Free falling, what is the acceleration? 9.81, right? ms -2. Right? It is going down with the acceleration of 9.81, right? So how to calculate? W bigger, right? Because it is going downward, right? W minus R is equal to MA. W minus R is equal to MA. Then I write the FR first. FR will be equivalent to MA. Right? Resultant force will be W minus R. W minus R. Why? Because it's going down. Alright. W mg minus R is equal to MA. M 50. Alright, MA. M 50. G 9.81 minus R is equal to MA. M 50. Oh yeah, not enough space. I hate it, you know. 50 times A acceleration 9.81. Not enough space, sorry, I got not enough space. Yeah, so annoying lah. But never mind lah. Right, so now 50 times 9.81. This one negative R move to here. This one also 50 times 9.81. So your R gonna be 0. When you see free falling, because of you cannot compress the scale, so it will give you no reading, 0. Do you understand it? Do you understand it? Yes or no? I try to fix it. Do you understand it? Any question? You got any question? Okay, nice. Just nice. Yeah, June, like that. Okay, nice. Everything just done. You got any question from here? Got any question? Okay. Now, all right. This is one of the example. Very easy example. All right. So we are going to do the second example. Right? We are going to see this kind of question. Now, find the acceleration and tension of the rod. Find the acceleration and tension of the rod. Now, first of all, what you need to do, the question not asking you how to label, but you need to learn how to label it. Question will give you mark. If your calculation is not correct, teacher, the marker will mark through your drawing, will give you consider to give you 1 mark or what, right? Now here, this is the weight, all right? This is the weight. This is the tension. This is the tension. Because of too hard to see, so I am going to draw. It's inside the tension. It is here actually, right? Never mind. I draw it here. I hope you can see. So we are going to label all the forces, right? This tension and this tension will be the same. Why? Because they are sharing the same pulley. What is this? This is a pulley. This is a pulley. Right? Pulley in BM we call takao. This is pulley, and this pulley, it is totally smooth, no friction. If got friction, you cannot calculate. They will not ask you friction on in Form 5 level. Right? TAKAL. Yeah, takao. Taka. Taka, this one, right? Pulley. This is the pulley. So this pulley, now we are going to have some force at here, right? So we are going to have the force at here, right? This one is called weight. Weight. So this weight we can calculate first, right? If you want, all right? So W is equal to mg. W m to g 9.81. You can calculate. How much is this? Calculator. 2 times 9.81. Right? You get your calculator. 2 times 9.81. How much is this? 19.62. 19.62 Newton. 19.62 Newton. Right here. We got first one, the weight here. How about this weight? W is equal to mg. Now this is 3 kg. This 3 kg is slightly heavier. Right? 3 times 9.81. So what will you get? $29.43. Alright, and then these two tension, it is always against the weight. This weight is going down, this tension will go up. This weight is going down, this one is going up. And then this tension always point toward the pulley. Right? Always point toward the pulley. Now I am going to teach you a harder way to do it. Later, I got the easier way to do it also. Right? I'll show you the easier way later. Now, I want to write the equation. When I want to write the equation, so I am going to put it into two different parts, right? So this one, and then two part, right? So I'm going to divide it to two parts. The first part here, it is, I do the left hand side part now. Right? The left hand side part here is, which one it is bigger? Do you think it is going up or going down? What do you think? It is going upward or downward? This one 2 kg, this one 3 kg. This one go up or go down? This one go up or go down? Answer me. The left hand side, 2 kg object. Go up or go down? Answer me. Go up or go down? Go up or go down? Go up, go down. I mean, go up or go down? Hello? Up or down? This one, the left hand side, the box here, go up or go down? Answer me. Hello? Just up or down, just like, yes, up. Why? Because it is lighter. Yeah, 2 kg lighter, then it go up. Oh, I know it is going upward. If you don't know whether it go up or go down, you just simply draw up or down, up to you. But if you said this one go up, then this one have to be go down. If you said this one go down, then this one have to go up. Also can. Don't mind one. Right? But if you know the one that correct one, it will be better. Alright. Now I want to write the first equation. You see how I write? Now, resultant force is equal to MA. Right? Net force is equal to MA. Right? So I want to write this one. Because of this one go upward. So I said T minus 19.62. Right? T minus W. Minus W. T minus W. The bigger minus smaller is equal to MA. M2. A, don't know. Alright. Now we know T is 19.62 already. T minus 19.62 is equal to 2A. How many unknown here? Which is T and A. Got two unknown. Alright. They ask you to calculate acceleration. Yes. They ask you to calculate tension. Yes. Right. You got two unknown here. Two unknown here mean you need to have two equations to solve it. Two unknown mean two equation. One unknown, one equation. So I am going to leave it as one. Equation number one. Equation number one, I'm going to put it to here. Now I want to do the second equation. Alright, second equation, how to do it? Now, second equation, I must go to the right hand side, this box. Right? Left hand side, I have done it. Right hand side. Which one is bigger? Which one it is bigger? W is bigger. Why? W is bigger. Because it is going downward. Right? W minus T. Tension of the rope, tension of the rope, is equal to MA. Right? So we got F is equal to MA already. I don't want to rewrite it already. You know it already. You know better than me. W, we know the W. Don't look at the left hand side box. Look at this box. Right? Weight is 29.43. 29.43 minus W. T. T I don't know. M I know. M is 3. Not 2 anymore. Look at this one only. 3A. This is the second equation that you have. You got the second equation already, right? You got two equations already. So now you can solve these two equations, right? How to solve them, right? The fastest way will be you plus them. Because this one got T, this one got negative T. This one got T, you got negative T, you eliminate them. Meaning that first equation, you always plus them, right? You will find it always plus, right? Plus the second equation will be equivalent to, right? I plus the first equation, T plus negative 3, no more. Negative 19.62, negative 19.62 plus 29.43 equals to, then right hand side, 2A plus 3A. 2A plus 3A. Then this is what we have, right? 19.43 minus 19.62. 29.43, I'm sorry. What am I saying? 29.43 minus 19.62. 19.62 equal, right? 9.81, we got here 9.81. 9.81 is equals to 5A. Then your 9.81 had to be divided by 5. You get 1.962. Your acceleration gonna be 1.962 ms negative 2. Can you follow? I hope you're okay. You find it is getting slightly harder already. Not like previous, right? So if you miss this part, right? You see if you join the group, you know they will keep on asking it every week. I answer until I can answer. Telegram group. These few months, not few months. These 2 weeks, I never answer question there, unless you are in my group. Right? If not, I don't want to answer because too busy. I cannot finish all my work. When I'm busy, yeah, I'm okay. I'll answer it. All right. Now, when you got this one, all right, substitute in from 1. All right, from the equation number one. From the equation number one, what do you have? Right, t minus 19. T minus 19.62 is equal to MA. M is 2. A 1.962. 1.962. Right? T minus 2A. So you bring the 19.62 to the other side. T gonna be 1.962 plus 2 times 1.962, 2 times 1.962 plus 19.62. You will get it as 23.544. 23.544, yeah. 23.544 Newton. Do you get it? Can you follow? I still got another example, no need to worry. But before I do another example, then I said I got an easier way for you, right? So now, what do I mean is the question not asking you the tension. Just ask you the acceleration. You can one way ticket. One way finish. Just very easy. Right? So you write F is equal to MA. Imagine it, right? This one got people pull with 2 kg. This one got people pull with 3 kg. So I will just say that it is something like I bring this thing to here like this. And then this thing is here like that. So 2 kg and then 3 kg. So change this one to force. You have to times 9.81. So meaning that it is some kind like here it is, you got one force pulling. You got one force pulling here. This force it is 3 times 9.81, 29.43. This force it is 19.62 Newton. Okay, you get it? Where will it go? Of course, where will it go? It will come to here lah. This is a total mass. Total 2 times 3. 2 plus 3, not 2 times 3. 2 plus 3 is 5 kg. All together the mass. 2 kg and 3 kg you combine together. One pulling here is 29 minus bigger minus smaller. It's equal to total mass. Right? So what you have is find the A, right? F is equal to MA. F is 29.43 minus 19.62 is equal to 5A. We calculate the A. We are going to calculate the A together. 29.62 in objective, but in structural you have to do it this way, no choice. 29.43 minus 19.62 divided by 5. You got an A. Right? You got an A. 1.962. But you want to calculate tension, tidak boleh. I told you, if you want to do this way, objective, they ask you, find acceleration. You pakai this way, okay. But if you want tension, you still need to come back to write the equation. So you have to learn how to write the equation. If they don't ask you, you can do it this way very fast. Very fast. You get what I mean? Now, question? Any question from here? If no question, then I'll question myself. Alright. Whereas this one for your understanding only. Right? Whereas it is not that Not that important lah. Alright. So now you see I got a pulley here, pull with an object 2 kg and pull with 3 kg. Alright. 2 kg and then 3 kg. Here, exactly the same. Alright, this is my question. And here, this is called tension. I label it first. This is called tension. This is called weight. Weight is 29.43, 29.43. This is the weight, 19.62. Right, I got these two. Now, I said this one is lighter and it should go up, right? What if I said I go down? This one go up. If this thing go down, then this thing had to be go up. If in this case, right, I don't know you intentionally draw it wrongly or you don't know you draw it wrongly. Whatever, I don't care. If you do it wrongly, just don't care. But I advise you don't do it purposely, don't do it wrongly lah. Right? So I do the left hand side. Right? I do the left hand side. So now I said it's going down because this one is bigger. 19.62 minus T is equals to 2A. I write the first equation for myself. I repeat one more time. Because I said it's going down. 19.62 minus T is equals to 2A. 2A. MA. Then I want to write the equation of this side. This side. Alright. And this side it is going upward as I told you. I already draw it. Don't ask me why. I also don't know why. Because you want to do it this way, then I follow you. Right? This one is going upward, right? Upward. So meaning that T is bigger. T minus 29.43 is equals to 3A. MA. Solve them. Negative T, cancel. Positive T, cancel, no more. 19.62 minus this one is equals to 19.62 minus 29.43 is equals to 5A. You plus them together. 2A plus 3A, 5A. You plus them together. 19.62 minus 29.43. 19.62 minus 29.43. 19.62 negative 9.81, and then I divide it by 5. I'll get negative 1.962. Still same. A is equal to negative 1.962. But once you calculate the tension, right, substitute into 2 or substitute into 1. Don't still use the negative. The negative cannot buang. Right? 19.62 minus T is equals to 2A. A is negative 1.962. Right? So 19.62 minus T is equals to 2 times this. Right? Times 2 Times 2 You get 3.924. Negative 3.924. Right? And then this negative bring to here become positive. This one bring to here become positive. 19.462 is equals plus 3.924 is equals to my positive T. Right? So I press it. I lazy to press. I time negative 1. 3.942 3.924 plus 19 plus 19.62. 33.544 my tension. Tension is 23, I'm sorry. Double check 23.544. Tension gonna be 23.544. Exactly the same. Now why negative? because your direction salah lah. This one should be go up. Oh, I know. So if they ask you find the acceleration, you cannot answer negative 1.962. No, no, you will not answer negative. Negative mean your direction, your assumption is wrong. This one lighter mana turun, tidak boleh turun, mesti naik. This one heavier, should be going down. How can be going upward? Cannot be. But I told you, you want to draw down, then draw down. You want to draw up, then up. One up, then the other one down. You get the negative, doesn't matter. You continue to calculate. Don't say, teacher, I get the negative, I become positive here. Then positive, oh, this one become minus. Salah lah, everything. If you know it is going up, then very well. Go ahead. If you know it is going down, yes, go ahead. If you don't know, simply cincai choose one. Do you get what I mean here? I don't want to screenshot it. Okay, we are going to do some more example. All right, these two examples will be good enough already, I guess. And then we do some exercise before we go do some quiz. All right, so we are going to continue to do here. Right, I help you out. Okay, now find the acceleration or tension of this rod. Right, so first of all, what we have is you got this one. This is called weight. W. W is equal to mg. I don't want to write mg already. Right, I straight away press the calculator. 4 times 9.81. 39.24. 39.24 Newton. Okay, are you okay? Here it is the weight of the 2 kg object. W is equal to mg. W is equal to mg. Right, 19.62. I guess you know how to memorize this already. Right, we do few times. Right, 19.62. 9.81 times 2 is 19.62. And here you got a tension. You got a tension at here. Do you see a tension? Do you see a tension? I showed you what is tension last week. Right, this thing, tension always go up. No need to worry. Tension always go up. Now I'm curious about this one, the right hand side, the left hand side. This thing, it is go up or go down. What do you think? Up or down? Left hand side. Left hand side. 4 kg object is moving up or down? Up or down? 4 kg object, it is going up or down? I saw your answer. I don't know correct or not. I will know it later. I bought it first. I know who bought it already. Janine and CX. I don't know who is CS. CS. Three words. Four words. Right. Only 4 of you are active. Other is passive. Sleeping there or what? I don't know. Six words. Alright. So you got 3. So you got 2 or 3. If you are PTSC student or you are non-PTSC student, you also can answer and you also can join my quiz. It is okay. But your mark will be not recorded in my system. That's all. Right? If you are not PTSC student. Right? If not, it mean you don't register lah. You don't register under the Google form, then I don't record your mark lah. Right? So I hope you're okay. Okay, all put down. All right, very good. Because obviously the cikgu, this one lighter bar, heavier must be going down. Yes, you are right. You're so smart. Right. So now I want you to take out your exercise book and try to write the first equation on your own, the left hand side. The equation for this one, bigger minus smaller is equal to MA. I want you to write resultant force. This one you want to write, it's first one, it's okay lah. Alright, second one I lazy to write sometime. Alright, help me to write the equation. You can put in number and substitute it and label it as 1. Okay, already. Alright, because of it, you said it is going downward. So 39.24 minus T is equal to 4A. Am I too fast? 39.24 minus T, bigger minus smaller, is equal to 4A, MA. Alright, this is the first equation. If you got the first equation already, you want to get the second equation, you can go ahead with the second equation. Now, you build the second equation, right? The second equation, it is from here, this side. This side, bigger minus smaller is equal to MA. Bigger minus smaller is equal to MA. Alright, should be okay for you. T minus weight 19.62 is equal to 2A. T, this bigger minus a smaller one. This one made me think of my student previously. Right? I tell you how, right? I don't know lah. I teach this one, she cannot understand at all, right? Until lastly, I use my ultimates, right? The strongest skill, highest level skill, then Baru can understand, right? I teach this one cannot, teacher cannot, don't understand why. I understand up or down cannot at all, whatever all cannot. So until I said, every time you see this kind of question, you just do left, right. Previously, she's okay, right? KG. Now I said, you see, this one got T, tension. She said, okay, boleh. This one got, this one okay. MG, OLED, boleh. This one can, no problem. Right, this one 39.24. Boleh, this one okay, no problem. This one's got tension, also okay. Now this one go up or go down, don't know. I said simply, you want left, then left, right, then right. If this one left, the other one right. If this one right, then this one left. All right. So if you know, oh, weight is more, all right, this side is. Ask this way, you can do or not? Can. This one minus this one is equal to 39.24 minus T is MA. 4A. Yeah, I know, Jegu. Then every time you draw it this way, lor. What can I do? Teacher, up down I cannot. Left right I can. Yeah. Ultimate say change it to left right. Same thing. Same thing. Right. 39.24 minus T is equals to 4A. Same. You want me to twist my graph my that one 90 degree? I cannot right? Okay. Now you are going to solve it. Solve it. So 1 plus 2. Right, 1 plus 2. What will you get? This one plus this one is this one, and this one plus this one. Negative T plus T, no more. 39.24. 39.24 minus 19.62 is equals to 4A plus 2A. It is 6E. Right? So I'll take out your calculator. 39.24 minus 19.62 equal, and then divided by 6 equal 3.27. Answer is A is equal to 3.27 ms negative 2. And as I told you, after you have calculated, you get me the T. Right? T, I want to get it from here, is easier. T minus from number 2, 19.62 is equals to 2A. 2 times A, 3.27. Whereas your T is, calculate the T for me. Calculate the T for me. T is 3.27 times 2 plus 19.62 equal 26.16. 26.16 unit meter. Question. Should be okay, right? Should be okay. Now, I said, if they ask you to find acceleration, I said, we got an easier way. Big minus small. Alright. 39.24 minus 19.62 is equal to 6A. 39.24, 39.24, 19.62, 19.62, 6A. 6A. Ayo, senang lah. You can get A is equals to 3.27. Now you see, I don't even do this equation out, but I can get the acceleration. If the objective question asks you to find acceleration only, whereas later in my quiz ada, right? You want to spend time, you do equation, then you do equation. No, you don't want to do equation, you understand this way, go ahead. I don't force you, you must use this way. Never. Now question. Right? So now we are going to do the next question here. Now here, example number 16, here it's a smooth pulley. Here it is something pulling downward. Now this thing is something pulling downward. This one, it is something pulling upward. Right? And this one is called reaction. And then this one is called weight. Now I want to ask you, weight bigger or W bigger? Weight or W bigger for this trolley, 2 kg trolley? R bigger or W bigger? R bigger or W it is bigger? So small, huh? Okay, make it bigger. Sorry. Hey, next time you cannot see, you remind me, make it bigger. Because when I see, because I'm very near to the screen, I can see it clear. Right? Probably some of you are using handphone, so very small, very hard for you to see. Do let me know. R or W bigger? Answer is, this trolley go up or go down when I pull it? It is not going to go up or go down. It go left and right. Nah, no, not R. I know most of you will answer R. I know most of you will answer W. Whereas this object will move left, right. It is going to move to the right only actually. So it is not going up. This trolley, it is not fly to the sky. Not zoom like that. Not boom going down. Because got something to block it. How to it will, because this one no force pulling it. I don't believe I place the trolley there, the trolley will pull the 5 kg up. No, I don't believe. So I believe it will come into this way only. So it is not go up and go down. So R will be equal to W. Right? R will be equal to W. But they not asking you. Alright. So this one will not help you anything. Not helping you anything. And then I want to label all the forces in. This force, it is called tension of the rod. This force, it is called frictional force. This force, it is called tension of the rod. And these two tension, it is the same because they are sharing a same pulley. W is equal to 5 times 9.81. 5 times 9.81. So what will you get? You get 49.05. 49.05 Newton. Right. You want to write mg, okay lah. Up to you. Right. Okay. Now, this way I can write it, but no use for me to write it. No point. Alright. 2 times 9.81, 19.62. So, if I ask you how much is the R right now, what is the value of R? The question not asking me, but I want to ask you. How much is the value of R? How much is the value of R? How much is the value of R? Yes, very good, Jenny. Very good. 19.62. Yes, because it is not go up or go down. Alright, so here, this one I am going to divide it to 2 parts to do it. Here. Left hand side and this side. Now, do you think this one go up or go down? Should be going down, right? Impossible to go up, as I told you, right? Because this friction is not going to pull it, right? So this thing, because of susah lah, this error they are not asking, so I write it off lah. If not, a letter you confuse. This thing, it is moving to the right. Because I want to draw something there. Okay, so you want to do we do this one first. All right, you write the first equation first, this equation. This equation for me, you write on your own. All right, I told you, you prepare one what, not spook, like something like that, okay, like that, you write here, Karen, cakap ayam pun boleh, whatever pun boleh, okay, no problem. First equation, we are going to write it. Have you done it? I hope you're okay. 49.05 minus t bigger minus smaller is equals to MA. M is 5A. I got two equations. Deduct. Cannot do. Right. Bigger minus smaller is equals to 5A. Right. If you want to write the first one, it is okay. F is equals to MA. F is equals to MA. Right. Resultant or not resultant? F is equals to MA. You already understand. Right. Okay. So I got the first equation. Now you are going to write the second equation from here. Write this equation for me. Write this equation for me. This thing is accelerate to the right hand side. Already? Okay. So big minus small. Ayah. I didn't give the rough surface friction how much, oh? Ayah. You see my question got error. Cannot do. Ayah, cannot do. Sorry, Sorry, given, right? Frictional force is 10 Newton. Okay. Sorry, I forgot to give you. Forgot to give in the question. Yeah. No one asking me. I see my own mistake. Given frictional force is 10 Newton rough surface. So what you need to write? T bigger, move to the right. You look at this one only. Don't look at this one. Look at this one only. T minus friction. T minus friction is equals to MA. MA is 2A. Right? I got the second equation already. Right. Right. Then solve them. This T negative T plus this T normal T. 49 plus the friction. How much is the friction? 10. Sorry. Minus the friction. Minus the friction. T and negative T normal T. Right, normal T. 49.05 minus 10 is 39.05 is equals to MA. 5 plus 2, it is 7A. So I can calculate the A. 39.05 divided by 7. 39.05 divided by 7. I'll get 5.578. Because of this question, I don't give friction. I don't give friction, so this answer is wrong. Wait. This answer is wrong. When I set the question, I do give. I must give, right? I must. Just I forgot to write. What's the answer? 5.57. 5.579. 5.579. 5.579. 5.579 ms negative 2. Then substitute here to get back to your answer, right? So get back to your answer. T is T minus 10 is equals to 2 times A, 5.579. You see, I don't round off. Now this number I times 2. Times 2 and then plus 10 is equals to my T, 21.16. 21.16 Newton. That's all. Now, of course, I know what were you gonna ask me. Teacher, isn't it supposed to be this way? You will ask me, Cikgu, is it equal to this way? I simply draw. I don't want to spend too long time on drawing this. This is 2 kg, this is 5 kg. Now, isn't it? Now, teacher, this one got a 19.62. Wait. 19.62. I know. This one got 49.05 Newton. This is tension. This is tension. I all understand. This one got one frictional force. Yes, I also understand. So now this thing is heavier, it going down. This thing it is going right. So isn't it equals to this one minus this one? 49.05 minus T is equals 5A. Yes, you are correct. 49 minus this is equals this. You are correct. T, a lot of students do it wrongly. T, right? This T is bigger, minus 19.62, which is wrong. T minus this, you go where? This T minus this T, and then the direction is not same, not left, right. So you must minus the friction. Now this T, why this weight is not used? Because this one is balanced by the reaction. Wait, the question not asking you. Unless they ask you to find the reaction, how much? Oh, 19.62. Now, question. We are going to do some question together. All right. This is from the step paper. So we are going to see. And then after this, we are going to do some quiz. Right. Diagram 12 shows the force acting on the drone as it's moved upward with uniform velocity. Which statement is true? The resultant force is equal to 0. The resultant force is not equal to 0. The lifting force is smaller than the weight. Right? Question number 14. Question number 20. Question number 20. Answer A or B or C. Answer. Question number 20. The keyword. Keyword. Ready? Forward. Where is others? What's 6 what, huh? Right. Got 2 of you are sleeping. Right. So you got some of you said it is B. Now B is not equal to 0 is wrong. Why? They said it is moving upward with uniform velocity. If moving upward with uniform velocity mean from the first part here, moving up stationary, not moving, moving constant velocity, left and right, it is the same. Just now when we do this here, yeah, before this, now not moving up and down, it is the same. If moving up with constant velocity, up with constant velocity, up and down, still the same. When you see the word of constant velocity, mean resultant force is equal to 0. This one minus this one is equal to 0. Right? Mean this one, if I said R minus W is the net force, R minus W is equal to 0, mean R is equal to W. Why R is equal to W? Because equilibrium. Why equilibrium? Because constant velocity. Do you get what I mean? Answer is equilibrium, constant velocity. Yeah, most of you get correct. Okay, no problem. Right, this one answer will be A. Number 19. All right, 19. Diagram tensor OA and OB react when O. Right, so the resultant force is determined by using a parallelogram of forces. All right, this is what we've done last week. Right, you pull here, I pull here, so that is one resultant force, result of the force. Which one? Answer. Right, A, B, C, D. So this one you pull here, this one it is same as here. Right, this one you pull here, it is same as here. So this is called result of the force, resultant force. Resultant force, last week we used cos rule to calculate. Right, answer is O to C. O to C. O to C. Is that okay? O to C. Now I want you to try to do this. Right, whereas here, right here, now here you got one weight, right? 3 times 9.81 Newton. And then the diagram shows the X and Y connected to a string to a smooth pulley. When the system is released, this thing, it is going to accelerate with 4. Accelerate with 4. How do I know it is going down? Must be going down. Because this one, nothing to pull it. Cannot be going to the right. So this one is going to be 4. Right? 4. Here we got tension. Here we got tension. And then smooth pulley. And then what is a frictional force? Frictional force, don't know. I put it as F, okay? This one is T. This one is T. Alright. So I want, right? I want you to find the T for me. I want you to find the T for me first. I want you to find the T for me first. How much is the T? Write the equation for me. This is W. Resultant source will be for this situation. Going downward with 4. Going downward with 4. Already? So the bigger minus the smaller one, because this one is moving downward. So the bigger is 3 times 9.81 minus T, right? Is equals to T minus, sorry, write off. F is equals to MA. The 3 times 9.81 minus T is equals to MA. M is 3 kg, A is 4. Right? I got this equation. Three times 9.81. 3 times 3 times 9.81. 29.43. 29.43 minus T is equal to 12. Right? You bring the negative T to here, become T. It is 29.43 minus 12. T gonna be, right? Okay? But they are asking me the frictional force. We found this T. We have found this T. It is 19.43. 19.43. This 19.43. And then this one I don't have. Right? I want to do F is equals to MA. Because this one moved to the right hand side. Right hand side. So 19.43 minus. This is 19.43. Because of this one is 19.43. I found this one 7.43 lah. Where got 19.43? 17.43. 17.43 Right, this is my friction force. I don't know. This is 4. Right, so 17.43 minus F. Minus F. Frictional force. This one is frictional force. This is MA, 2A. Acceleration is 4. (17.43) is minus F is equal to 8. Bring the negative F to here, frictional force. This 8 move to here. 17.43 minus 8 is your answer. 17.43 minus 8. 9.43. Are you okay? A bit hard, right? But I guess if you follow all the way you follow, you should be okay. Right? This is most of the student they cannot do. You just divide it to 2 parts, will be okay. Now, if you see, as I told you, if I want to do it fast, how am I going to do it? You see, this one is 3 times 9.4, 9.81. This one is T. I don't know, right? This is F. So the resultant force will be F is equal to MA. The resultant force will be this one minus this one. 3 times 9.81 is equals to MA. Total mass 3 plus 2, 5A. A is 4. Alright. This one minus F. This F I move to here. This 20 I move to here. 5 times 4 is 20. So what should I get? 3 times 9.81. 3 times 9.81. And then minus. This one become plus. Negative F come to here become plus. This one come to here become minus. Minus 20. Equal 9.43. You see, so simple. If you know how to do it. This kind of question, yeah, I know they not asking me T. Don't ask me tension. Then I can do it straight away. Like what I taught you just now. Okay. Okay. Now we are going to continue to do it. Diagram 14 shows a trolley mass of 1.5 kg. Mass trolley 1.5 kg. Ooh, 1.5 kg. And then with the weight, pull by the weight, I don't know how much. Right? Acceleration is 2. Whoa, 2. Must be going down, I know. And the frictional force is 3. Yeah, frictional force is 3. Find the resultant force. Calculate a resultant force, right? Calculate a resultant force, Now, here, what is the weight? I don't know. Right? What is the weight? I don't know. So, weight, because of I don't have the mass here. If I got the mass, it is okay. What is this 1.5? A trolley. What is this 1.5? A trolley. Trolley pulled by the weight. I don't know how much, right? Now, if I want to find the weight, right? W, I do it fast, you see, W minus minus 3 is equals to MA. This M, I don't know. Total mass, this one plus this one, right? M plus 1.5 A. I got 2 unknown. Cannot. I cannot do it this way. Cannot, Cannot, I divide it to 1 by 1 to do it. Yeah. So I do this one first. I want to find the T. I want to find the T, Yeah. That is the tension. Here is the tension that I want to find. If I find here, too many unknown here later. So I want to find this one so that I got lesser unknown. Okay? Now, T minus 3. T minus 3. Because I know it is moving to this side with the acceleration. Right? T minus 3 is my net force. It's equal to MA. M. This one is 1.5. A is 2. A is 2. This one 2. This one 2. They are moving together. They are sharing the same pulley. Right? 1.5 times 2. T minus 3 is equal to 3 times 1.5 times 2 is 3. 3 move to here, it is T, it is 6 Newton. 6 Newton. I got the tension of 6 Newton already. Now I want to do this one so that I can find the weight. Alright, W minus T is equal to MA. W bigger minus the tension is equal to M times A. Right? So M I don't have. A I got 2, but I do it later. W first. W I don't know. Minus tension 6 is equal to MA. M times 2. Right? This is M times 9.81. 9.81 times M is 9.81 M. I bring this one to here, become 6, positive 6. This one I bring to here, become minus 9.81 M minus 2M. So 9.81 M minus 2M, it is 7.81 M. M is, I got the mass. Mass is 6 divided by 7.81. 6 divided by 7.81. 6 divided by 7.81. So your M is 0.6 at 676 at 0.76 at but they don't ask you this. Right? They ask you calculate the resultant force. Right? What is resultant force? Resultant force is this one minus this one. Right? So resultant force of the system is W minus 3. W is equal to mg. M 0.678. G is 9.81 minus 3. So this answer I don't round off. I times 9.81 times 9.81. Right? Minus 3 equal 4.53. Don't have answer. Wait. Calculate the resultant force act on the trolley. Trolley only. Alright, sorry. No, they want trolley, not into this system. They want trolley only. Trolley is 6. Resultant force 6. I don't know why do I do this. They ask me calculate the resultant force act on the trolley only. Trolley only. T minus 3. How much is T? 6. I calculate. So 6 minus 3. Answer is 3. If the system will be this one, 4.5, the whole system. Trolley only is T minus 3. Answer is 3. Oh, I see much enough. I want to do some. Yeah, cannot finish. I do one more example before we do some quiz. Alright. I mean your quiz. Cannot. If I don't give quiz here, letter cannot finish. So I give you the quiz. Alright. For those who that one, right? You are behind. Please. Please drag to the front so that you can join the quiz fast. This one I'm going to do it next week. This one we have done it so many times, right? This one also. So this one we are going to do it next week. So I am going to give you the quiz right now. Give me 1 minute. Join the quiz, huh? Okay. Give me 1 minute. Okay. Join the quiz. Join the quiz. If you're a PTSC student, follow what I do. Right? Follow like what I told you previously. Put the number so that I can key in easily for you. For those who are new, it is okay. Right? I'll tell you next time. Join the quiz right now. Like yeah, PTSD student I know, PTSD student I know. If you haha, I don't know who are you lah. Later I cannot key in, right? If you are PTSD student, you quit first and then you rejoin later. I'll wait for you. This one is Chen Si, next time Chen Si, next time you use this one, right? Because I got a table, Chen Si, you listen, Chen Si, your list will be 36, right? You use 36, you just join and you don't know how, but never mind. All right, next time you put PTSC 36 Chen Si so that I know. Three, four, five, six, seven. Right, is there any other? I want to start already. Is there any other? Is there any other that haven't joined yet? Are you ready? Right. Oh, okay, start. Yeah, I got some question. Resolution of force. I haven't teach. Yeah, cannot. I need to cancel the quiz. I'm sorry to you. I'm sorry. Because there is many questions that I haven't teach yet. Sign and cause, resolution of force. This one is not calculated. Right? I'm sorry. Because I thought today I can. My planning is I can finish the until here so that you can do a lot of question like this. I set a lot of question like this, so cannot resolution of force, cannot. So never mind. I continue to finish that one. That one is not calculated. All right, not calculated. I'm sorry. I'm sorry. I'm sorry. I'm sorry. Sorry. Okay, we continue to do some question. I'm sorry. I plan to finish it. Cannot. Okay, never mind. We do 21. I'm sorry. Okay. We do this question 21. I'm sorry. So guilty. Because I prepared it last week. Diagram 21 shows a two lots with the mass of 3 kg and 5 kg connected to a string. 3 kg and 5 kg connected to a string through a pulley. The system is released. What is the tension of the rod? Mean they ask you to find tension. Mean you cannot use shortcut already. You have to write the equation. Help me to write the equation here. Here. Write the equation here and here. This thing is heavier, so that it's going down. This thing it is lighter, so that it's going upward. Label everything in. So how are we going to do it? So this thing is heavier, right? So weight is mg. M it is 5, G is 9.81. 5 times 9.81. 5 times 9.81. 5 times 9.81. 49.05. We got here 49.05 Newton. Right. How about this? Here it is 3 times 9.81. 29.43. You got 29.43 here. This is called tension. The label for you. This is called tension. Sorry, this is called tension. And then this one is accelerating upward. This one is accelerating downward. So no matter what, you have to do the calculate the acceleration first. Do this one for me. So 49.05. 49.05. This thing is going downward. So downward here it is bigger. 49.05 minus the tension of the rod is equals to MA. M is 5. A don't know. Alright, the first equation. Now I want to write the second equation from here. The green one. Right, the second equation. This one is going upward, mean T is bigger. T minus 29.43. 29.43 is equals to 3A. So this is 1, this is 2. You plus the two equation together. Negative T plus T, no more T. 49 minus 29. 49.05 minus answer. Okay. 49.05 minus 29.43. 19.62 is equals to at A. 19.62 is equal to 8a. So a gonna be, you divided by 8. So answer I have to divide it by 8. Divided by 8. Answer divided by 8, you get 2.45. 2.45 your acceleration. Right? 2.45 don't have, because they're asking me tension. So I have to substitute in back to here. T minus 29.43 is equal to 3 times A. A is 2.45. Yeah, I should not do it this way. I mean, I should do it inside the that one. If I do it here, I cannot save. I cannot save into the file. Then I redo it later, huh? Because I almost finished already. I bring this under here. In answer is 2.45. I need to times 3. 3. Right? Plus 29.43. Plus 29.43. So what will you get? You get 36.79. 36.78. Boleh lah. This one. $36.79 Newton. Okay. Meaning that I need to do it here. If not, I cannot save it to you. Right? Here it is weight. Here it is weight. This one is tension. This one is tension. And then I got a T here, tension. So I got a weight at here. W is equal to 3 times 9.81. How much I forgot? 3 times 9.81. 29.43. Okay. So I got this weight, and then I also need to find this weight. How much is the weight here? Right. It is 5 times 9.81. Right? Which is, this one I remember. 49.05 Newton. Okay. Now I still know two things is this one is heavier, so that it's going downward with acceleration. This thing it is going upward with the acceleration. So I want to write the equation. Equation is big minus small. So I write this equation. This equation will be F is equal to MA. F is 49.05. 49.05 minus T is equal to 5A. First equation. This equation here, this equation will be, this one is going upward, so T is bigger. When T is bigger, T minus 29.43. Right, the upward force minus the downward force is equal to MA. M is 3. 3. 3A. So I solve them. This one minus this one. This one you plus them together. Right? 29.05 minus, not 29. 49.05. 49.05 minus 29.43. 29.43 equal, divided by 8. A is equal to, and I divide by 8. I'll get 2.4525. But anyhow, I want to find the tension. So substitute back T minus 29.43 is equal to 3 times A. A is 2.4525. Here, I need the time 3 times 3. And then plus 29.43. Then I will get my answer as 36.78. 36.78. Actually, the answer is not so good. My answer, I never round off. 36.79 actually. I use my own answer, huh? But here I circle 36.78. Can you follow? Kind of complicated, or kind of hard, or All right, the next one. Which one will give you the least minimum acceleration? Minimum acceleration. So we are going to do it here. We calculate the A. For A, F is equal to MA. The net force, help me. This one, net force. F, net force, big minus small. 3 is equal to 3A. So A is equal to 1. I don't put in the unit because this is objective question only. F is equal to MA, second one. F, net force. Net force. 10 minus 6. Right? 10 minus 6 is equal to MA. MA, 4A. So 4 divided by 4. A is still 1. This one. F is equal to MA. F, net force, big minus small. Big minus small. Add minus 7 is equal to 2A. So A minus 7 is 1. 1 divided by 2, it is A is equal to 0.5. At least this one is smaller. Last one. F is equal to MA. F, net force, add minus 7. 1. Is equal to 1A. So A is still 1. So which one will produce the smallest minimum acceleration? So answer is C. 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 Are you okay? I see I can finish it or not. Few minutes. Banyak. I do one more question before I end the class. Next week, we finish the resolution of force. Baru we do the quiz. Right. Diagram 18 shows a hot air balloon. It is moving with constant acceleration. Not constant velocity, acceleration downward. Downward. Alright. Now which one is correct? The weight of the... I label all the forces. This is weight. This is upward force. A force. It is called buoyant force. Which is you haven't learned. Next chapter, baru you learn. Right, this is weight. This is a buoyant force. Upward. And then this thing, it is going upward or downward. The question said, moving downward with acceleration. Moving downward with acceleration. I know. This question gives. Right? Which one is correct? The weight of the balloon increase. Yes or no? The weight of the hot air balloon increase. B. The resultant force act on the hot air balloon is 0. Correct or not? 0 means you still accelerate? No. The weight of the hot air balloon is equal to the buoyant force. If weight equal to buoyant force, then how can you... Right, how do you accelerate down? The weight of the balloon, it is bigger than the buoyant force. Weight is bigger than the buoyant force. That's why you move down. Answer? Answer? Answer is D. A, also you might be telling me that cikgu, weight increase. Oh, now why weight increase is wrong? Because the weight might be no change. This one, let's say 10 Newton. This one change. This buoyant force change. Right? It from 10 Newton, it become 8 Newton. I don't increase my weight. But this force decrease. Decrease mean this one is heavier, so it going down. The weight is more than the buoyant force. 100% correct. The weight increase may be correct. If no answer weight increase, then it will go down. Yes, boleh. But in fact, how do you increase the weight in the sky? Ask more people to jump in or what? No, you can only release the gas here or increase burn the hot air here, make it lighter, so increase or reduce the buoyant force. Buoyant force you haven't done. Do you understand it? All right. We are going to continue to do this one next week. Is that okay? I know you are tired already. Now, that is lot of question about this chapter. This chapter, resolution of force 1.1 and 1.2 is resolution of force. This is still resultant force. It is big part, right? If you missed it, you see how hard it is. The front part, then I tell you something very easy. But now it's starting to become more complicated. Got some calculation, got some concept in already. You need to know where go up, where go down, where is bigger, where is smaller. So I will give you more example next week before we do some quiz. Is that okay? Any question before I end the class? Any question? Yeah, if you're not there to ask me in the YouTube here, it is okay. Right? You PM me. I'm in the group. You can ask me in the group. Or you can ask me personally. You know my handphone number, right? You can PM me. Right? You can PM me, ask me question. And then the next thing is I want to do a bit of promotion is if your friend need physics tuition, and then you can ask them to join, you will get a reward. You get 10 ringgit per month every month, right? Unless she quit, he quit, your friend quits, or you quit. If not, then you'll join. You will receive the reward. Right? Ask your friend to join. Is that okay? Now it is free. After February, it will be start to 49 ringgit per 90 cent. If they join before March, in the February you join, you will enjoy this price. If not, then you will 65 every month. All right. Is there any question? If no question, then I'm going to stop here. Any question that you want to ask me? Okay, bye-bye. I'm sorry, just now I thought I had finished the part, right? I forgot the resolution. I haven't teach. I set the resolution in. The title is already resolution. Where do I teach it? I haven't teach it yet. All right, I'll see you next week. Bye bye. See you. Bye bye. Good night.